Okay, so in this video, we're still gonna be talking about power, but I'm gonna introduce the Millman theorem first. So, what Millman theory is saying is that, well, first of all, Millman is applied to a binodal network and is basically saying that the voltage of the boundaries of a double pole of the network is the algebraic sum of the short circuit current and the sum of the conductances. So if I gotta write it, I would say that V is equal to the sum K of I short circuit currents A over the sum K of GK, which basically says that, well, let me just write Millman is applied to binodal networks. Okay, and it's basically saying that the voltage of the boundaries of a double pole network is the algebraic sum of the short circuit currents and the sum of the conductances. Okay, so V is equal to the sum of K of ISCK over the sum of KGK. So in this example, we're basically gonna be we will find the value of J, which is the power dissipated, and we're gonna use the Millman theorem in order to do that. So let's draw our circuit once again. So our circuit this time basically going to be voltage generator plus V1, which we're going to call V1, a resistance, then a node, then another resistance. Oops, I should have been, yeah, this is supposed to be, I messed up the draw. Okay, let me just, yeah, I hate when it happens. Okay, so this is a voltage generator. Then we're gonna have resistance. Then here we're gonna have a current generator. Then we're gonna have another resistance and another voltage generator, which we're gonna call V3. And then we're gonna have a resistance. Okay, so we're gonna call it R1, R2, R3, and this one R. And the problem is saying for the circuit on the left, we know that Vi is equal to 10 IV and Ri is equal, well, and Ri is equal to R, which is equal to 1 ohm. Find the value of j so that the power dissipated by dissipated by the resistor R, in the resistor R, is null. Okay, so what does actually mean? Well, first of all, let me just draw something in the add something to the circuit. I'm gonna draw 2 points. This one is gonna be my point A. This one is gonna be my point B. I'm gonna say, okay, this is a difference of potential. I'm gonna call this VAB. Okay, I've done this before other times. The reason why I'm doing it here this time though is that in order to have PR equal to 0, I'm going to have VAB equal to 0. So let me just write it. In order to have PR equal to 0, I must have VAB equal to 0. So in order to have PR equal to 0, I gotta have VAB equal to 0. So this way I can apply the Millman theorem between the node AB by setting VAB equal to 0. I can use apply Millman theorem between the nodes AB by setting VAB equal to 0. Okay, and I'm just gonna do it. So we know that VAB is actually V1 over R1 minus J plus V3 over R3. Okay, so V1 over R1 minus J, that's going in this direction, plus V3 over R3, everything over 1 over R1 plus 1 over R plus 1 over R3. So now, as I said, I'm gonna be set all this equal to 0. So if I just substitute this with numbers, I would actually get this one is 1, so I will actually get 10 over 1 minus J, which I don't know, is what I'm looking for, hopefully, plus V3 over R3. So V3 will be 30 over R3, which is just 1. And then I would have 1 over R1, so 1 over 1, which is 1, plus 1 over R, which is 1 over 1, plus 1 over 3, which is 1 over 1. So, and all this is equal to 0, of course, as I said it. So this is actually 10 minus J plus 30 over, 1 plus 1 plus 1 equal to 0. Okay, so basically I can say, okay, I have 10 plus 30, so I have negative J plus 10 plus 30 is 40, positive 40. Now when 1 plus 1 plus 1 is 3. So over 3 equal to 0. So now I can just say Well, I'm gonna find J. So I can just, first of all, I'm gonna get rid of the denominator by multiplying everything by 3. So it will be just like negative J plus 40 over 3 equals 0 times 3. So those two cancel out. This one just gonna be 0. So it's like saying negative J plus 40 equal to 0. Therefore, negative J is going to be equal to negative 40. So J is just going to be equal to 40. 40 what? Well, 40 amps, of course, as it's a current. So that's it. Like, we found it was asking us to find the value of J, so that the power dissipated by the resistor R in the resistor is null. So we set it equal to 0 and we apply Millman. That's it. 40 amps. Simple as that.